Okay, this lesson is on average velocity. Now you should have already have learned about scalar and vector quantities and about distance and displacement. So today we're going to talk about average velocity. Some things that we need to know. Average velocity is defined as the rate the displacement changes over time. So what we're going to be concerned with when working these problems is displacement, not total distance. And the displacement is the change in position, wherever you start to wherever you end up. To solve for average velocity, we need this equation right here, v equals delta d over t, or v equals delta x over t. Now d and x can both be used when we're talking about displacement. It doesn't matter which one you use. I like to use D, but some people use X. Now, V stands for velocity, and we measure it in meters per second. We always want our velocity in meters per second. Our delta D is our change in displacement. It's measured in meters. We always want it in meters. And T is for time, and we want those units in seconds. So if we're given something, a velocity in kilometers per hour, we want to convert that to meters per second before we work the problem, and we do that by dividing by 3.6. You need to write this down and memorize it because you'll be using that a lot over the next few days. Also, if we're given a displacement in kilometers, we want to change that to meters, which is by multiplying by 1,000 or moving your decimal 3 places to the right. And if you're given a time in hours, you want to convert that to seconds. I think you can multiply by 3,600. Or if you're given minutes, you want to convert that to seconds, multiply by 60. Now, if we look at the first example problem, and you have the notes, I provide you with the attachment that goes along with this. You can watch this and write down your the solutions of these problems and then refer back to those notes. If we look at the first problem, it says a student travels 11 meters north and then turns around and travels 25 meters south. If the total time of travel is 12 seconds, find the student's average velocity. Again, we are concerned with vector quantities of velocity, not speed, and we're wanting to deal with displacement, not distance. The total distance this student would have traveled would be 36 meters, but we're not looking at distance, we're looking at displacement. So displacement would be from where they start, right here, to where they end up. So, and it has a direction. Since it's a vector quantity, displacement has a direction associated with it if you're given a direction in the problem. Some problems won't have a direction and you don't have to worry about it. But sometimes you will be given a direction and you need to show that. So if you go 11 meters north and then you turn around and go 25 meters south, the displacement is going to be from here to here, where you start to where you end up, and it's got a direction. So we would have to subtract 25 and 11. That's what the triangle there means, a change in how your displacement changes. You would subtract to get that, and it would have that would be 14 meters, and it would have a direction. Since your going south was a longer distance than going north, it's going to be 14 meters south. If these would have been in the same direction, both of them going north, we would have added them together. All right, and this arrow, what I said point down, is actually the 14 meters south displacement. I can move that arrow over to the left and to right here, and it would fit there to show my displacement. All right, so my displacement is 14 meters per meters south. If I look at what the other parts of the problem, we're going to use what is the guess method to solving these problems. G stands for givens. We're going to write our givens down. U stands for unknowns. We're going to write our unknown down. E stands for equation. Write down the equation we're going to use, because in this unit we're going to use about 5 different equations to explain motion. The first S is substitute. And the last S is solve. I would suggest that you use this method to solve these problems where you won't make mistakes. For these first set of problems we're going to do are pretty simple, but they're going to get a little bit more complex. And what I mean by givens, so we write down our displacement was 14 meters per second, or excuse me, meters south. And then it says if the total time of travel is 12 seconds, so T is 12 seconds. What's the student's average velocity? So what is V? It's going to be our question mark, and we know it's going to be in meters per second. All of our units have to match up. Alright, next we're going to write the equation we're going to use. We're going to be using this equation on all these problems today. Then I'm going to substitute and solve. So for velocity is equal to, for displacement, I'm going to put in what the displacement was over time, which was 12. So 14 divided by 12 is 1.1666 repeating. So I want you to round your answers to 2 decimal places. We can be, instead of going by significant figures, let's round it to 2 decimal places so it will all be consistent. So I'm going to round that to 1.17. Then my units are going to be meters per second, so I'm talking about velocity. And then put a box around your answer. Always show all work and calculations, and don't take any shortcuts or you'll end up messing up on these problems, especially when they get a bit more complicated. Alright, the next one says, how long does it take a car traveling at 45 kilometers per hour to travel 100 meters? Alright, so I'm going to write down my givens first. Car traveling at 45 kilometers per hour. That's going to be my velocity. And my change in displacement, if you notice, it didn't give me 2. It just gave me one number, so that's telling me what my displacement is. And time is going to be seconds, but I have a problem. If you notice, my velocity is not in the right units. I'm going to need to divide that by 3.6. And it gives me 12.5. And that's meters per second. And now my units match up. I have meters per second, and then my answer will be in seconds. So next I'm going to write my equation again, same one. And I'm going to substitute and solve. Okay, in this case, I have to solve for t, and I'm just going to use algebra. I need to, instead of, my t is my x, it's my unknown. I'm going to leave it, I like to leave it as t instead of putting an x in there. just because it's better to do physics problems that way. So I'm going to multiply both sides by t. It cancels on this side. And this ends up being 12.5 t times time is equal to 100.0. Then I can just divide both sides by 12.5. Cancels on the left, and I'm left with t is equal to 8. I want to show my answer 2 decimal places, so a whole number would just be 8.00, and its time is going to be seconds. Okay, the next problem. It says, how far does a skateboarder travel in 22 seconds at the average velocity if his average velocity is 12.0 meters per second? So first it gives me, it says travel in 22 seconds, it's telling me the time. It says my average velocity. And how far, so we solve for my change in displacement. My units are what there should be. Velocity is in meters per second, time is in seconds, so it's going to give me my displacement in meters. So then I write my equation down, B equals delta D over T. I'm going to substitute and solve. In this case, I'll multiply both sides by 22. My answer would be 264, and again I use 0.00, come out as a whole number. I'm going to go 2 decimal places, and my units would be meters. And I'm going to draw a box around my answer to separate it from my work. Alright, the last problem in the work is number 4. It says a shopping cart moves from point 3.0 meters west of a flagpole to a point 18 meters east of the flagpole in 2.5 seconds. So it's giving me a couple of different displacements here, so I want to, you can always draw a picture to help you out. And if we have this, man, I can't draw very well, but this flagpole, you got this distance here, which is where he starts from a point from right here. If we say this is 3 meters, but this is where he's starting from, and it's going to a point that is 18 meters. To the east. So you have to really pay, pay close attention to how the problem's worded. We can figure out your displacement. So if he starts here, he goes these 3 meters, and he goes all the way these other 18 meters. That would be a total displacement of 21 meters. So my change in displacement is 21 meters. And my time is 2.5 seconds. And then I'm looking for and that's really I should be looking for my velocity. I just left that out accidentally. And that's going to be in meters per second. Our equation again. Then I'm going to substitute and solve. And that would be 8.4, so I'm going to show that as 8.40 meters per second. And in this case, I could use a direction because this would have been 21 meters east. So I would want to include that in the answer since it gave me a direction.